So we'll do this one step at a time. And last time I was mentioning about the Boolean difference idea. Now, as you remember, Boolean difference idea is based on the fact that all tests are included in this expression. That means f is the normal function, f alpha is the faulty function. So when the normal function and the faulty function, when they have different output, that combination is a test. And hence all the tests are included here. And that led us to the Boolean difference method. And according to Boolean difference, all the tests are included in the expression. And this is for x of I stuck at 0, and where we define the term df by dxi. So this is basically the set of combinations for which the output is sensitive to the value on line x sub I. And we had last time given that as where by this notation I mean this is the same thing as f, except x sub I has been replaced by 0, and here x sub I has been replaced by a 1. And similarly, for if you want to consider xi stuck at 1, the only difference you need to make is instead of xi, you will have xi bar. Otherwise, the same thing applies. So let's look at an example of the Boolean difference method. Now notice, Boolean difference method is an algebraic method. And if there is a test, Boolean difference method will find it. If the Boolean difference method does not find a test, if you find that this gives you 0, that means there is no test. And it will find all possible tests. So in a way, this is a nice technique because sometimes you want to make sure that there is indeed no test. And this will tell you that. Okay, here let's look at an example of Boolean difference. And let's consider this circuit. Let's put an inverter here. Now the normal function, which is a function of a, b, and c, is, as you can easily verify, is equal to ab plus b bar c. Now let us consider the fault. Let us assume that the fault happens to be line B stuck at 1. So here we have a line B which is stuck at 1. So we have to find a test, or rather more accurately, since we are using Boolean difference, we need to find tests for this line stuck at 1. So according to the theorem, the tests are T, and that is equal to complement of B multiplied by dF by dB. And where we need to figure this out, right? So notice that since this is stuck at 1, obviously you want to apply a 0 there to possibly test for that fault. Okay, so let's try to find dF by dB. And here is, okay, the value of the function with b set to 0. Why don't I do that in 2 steps? Okay. So according to the Boolean difference theorem. Okay, how much is this? When you set b equal to 0, so this term drops out, this becomes 1, so this is just C, exclusive OR with, okay, how about this here? We make a b equal to 1, so this is 0, so this drops out, and this is just A, and of course that is equal to AC bar plus A bar C. But of course we are not done yet, so we want to get for test equal to D bar and the width this. And hence we have the 2 combinations. So the tests are, we can write this in binary form, 1 0 0 and 0 0 1. So we have 2 tests, and perhaps we could try one of them and see if it will work. How about maybe we try 1 0 0? So we apply 1 0 0. And notice that here this is stuck at 1. So normally this is 0, but in case of a fault this is 1. So this is normally 0, and in case of a fault that is 1. Maybe I'll do it this way. Normally, this here is normally 1, but in case of a fault this is 0. This of course is just 0. So this here is going to be, so this is 1. So this is normally 1 in case of a fault 0. And this here is, what is this here? Normally this is a 1 coming here and a 0, so they have a 0. So you have a 1, and in case of a fault, let's see. In case of a fault, this is 0, so this is still 0. That's still 1. So let's see, have I done this correctly so far? And you have to watch and make sure I'm not making a mistake. Okay, so here, so this is normally 1, and this is normally 1. So this is 1, and hence this is 0 normally. And in case of a fault, this is 0, and hence this is 0, and hence this is 1. So the normal output is 0, faulty output is 1, and hence this is a test. That is the definition of the test. So basically, the definition of a test is that for a given fault, if the output is different from normal, then that combination is a test. Any questions on this? Okay, now let us, so far, we have this here is in terms of primary inputs. So X of I is what's one of the inputs to the circuit. Now what if you have a fault on one of the internal nodes? Then how would you apply the Boolean difference method for an internal node? Oh, incidentally, I guess this is a good time for a quiz. So let's have an online quiz. And so let me make an online quiz, and I will make it available probably around 5 or 6 o'clock this evening. And I will give you maybe today's Thursday, right? Maybe until Tuesday evening or something like that. How does this sound? So, and let's see. You can take it. Let's make it 2 times. So, it would be a sort of a review thing, and this will be on RAM-CT. Okay. So, internal notes. Okay, so basically the main thing is that we need to keep track of what internal node is. So you have basically some internal node, which is H, which is some function of the inputs. So basically we would express the original function Oh, incidentally, I was looking at some of the recordings yesterday on YouTube, and I think they look okay. I probably need a teleprompter so that I can speak as well as Barack Obama. But I guess until that time, I'll use the low-tech method. Look at my notes to refresh my memory. Okay, so basically the idea is that you need to express the original function, which was f, and this is a vector, as a slightly different function, and let's call it h, which is a function of the original inputs and the internal node. Then test for h stuck at 0 would be given by this. So basically, the idea is still the same. You need to sensitize the fault. So if h is stuck at 0, normally you would want h to be a 1. H is some internal node. And then here you need a set of conditions for which the output is sensitive to the value at line h. Okay, let's look at an example, and let's start here. Okay, let's consider this circuit. And let us assume that line H is right here. This is H, and this line is, let's make that stuck at 1. So our objective is to find a test for this line stuck at 1. Now this is how we would approach it. In a normal function, which is a function of A, B, and C, we write that as AB plus B bar C. Now this internal node H, which is a function of A and B, is equal to A ended with B.